Hello, everyone. Welcome to another live session at the Reactor. Before we get into the session, please take a moment to read our code of conduct. We are all here to learn, so please be respectful of other people's views, understanding of differences, and be kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you to participate, leaving your questions and comments. Today, we have an introduction to data science and Python basics with Eniola. So let's start inviting Eniola to our virtual stage. Hello, Eniola.
Hello, everyone. Thank you, Larissa, and welcome, everyone. And I am excited to be here this morning, and I will be sharing my screen now. Hello, everyone. Can you hear me? Hello.
Yes, we can hear you well.
Hello, can anyone hear me?
Hi, Eniola. Can you hear us? Yes, we can hear you.
All right. I'll get started now. Okay, I welcome everyone once again to this Data Dive Bootcamp. And this is the first session we will be having on this bootcamp. This bootcamp is a collaborative effort between Microsoft Learn student ambassadors in Islamabad and Nigeria. Okay, so this is the first session, and I'll be taking you through the fundamentals of data science and machine learning, as well as Python basics. So I'll be doing a quick introduction of myself. My name is Eniola Ajala, and I am a front-end web developer, technical writer, data science and machine learning, and I'm also a Gold Microsoft Learn student ambassador. Okay, I'll be proceeding to showing the session outline for today. And the first thing is defining data science and machine learning, then moving forward to data science ethics, supervised machine learning, working with relational data, working with NoSQL data, and then I'll be sharing my VS Code to show you some Python basics. But before we move forward, I would like to make a quick announcement. You have to join the Cloud Skill Challenge. If you can see my screen, there's a link down here to join the Cloud Skill Challenge. This Cloud Skill Challenge would help you understand better what this bootcamp is all about, and it will speed up your progress rather in learning data science and machine learning. So just click on the link, and I want to see everyone on the leaderboard as you join the Cloud Skill Challenge. Okay, so let's get started now. Okay, first, defining data science and machine learning. As I put here, data science is an interdisciplinary field that combines domain expertise. Domain expertise like, programming skills and statistical knowledge to extract insights from data. So basically, data science is an art of, getting data and working on that data to actually get useful insights from that data. Maybe at one point or the other, many of us here might have filled out a feedback form or completed a questionnaire or a survey. Actually, the essence of the survey, questionnaire, or the feedback form is for the person to analyze the data gotten at the end of the day, then make reasonable conclusions or solutions from that data. So as I put here, it involves programming skills. Of course, you can use Python and For some no code and low code tools, you can use Azure for that. So it involves domain expertise in programming skills and statistical knowledge to extract insights from data. This statistical knowledge would help to understand what your data actually represents. If you are checking the mode of the data, the mean of the data, you can easily know, okay, this is what this particular data represents at this instance. Okay, so moving forward, I would be talking about machine learning, which is a subset of artificial intelligence that focuses on developing algorithms and models that enable computer to learn from data
Okay,
and make
Daniela,
predictions.
sorry,
Actually, machine
sorry
learning
to
is
interrupt.
just you telling your
Can you hear?
machine, training your machine. Hello,
Hi, sorry to interrupt you, but we are not
hello,
seeing.
am I?
Hi, can you hear us? We are not quite seeing your slides moving. We are just seeing your PowerPoint view with the first slide.
Okay, it is not moving. Okay, let me quickly
Yeah.
work on that. Sorry. Okay, I guess I'll stop sharing my screen, then do it again right now. Okay, is it visible now? Can you see my
Yes,
screen now?
yes, it is. It is. Yes. We are not
All
seeing
right.
you.
Okay, sorry. Okay, it's back up now. Okay, so the link to the Cloud Skill Challenge is here, and it will be sent to the chat. And okay, so this is the slide for the data science and machine learning definition, which I said data science is an interdisciplinary field that combines domain expertise, programming skills, and statistical knowledge to extract data to extract insight from data. Okay, so I was talking about how machine learning is just you basically training your machine and telling your machine what to do. So next time you ask your machine questions about what you've trained it on, it can answer you fair and kind. So data science and machine learning work together in the sense that after collecting your data, analyzing your data, and getting insights from this data, right, you can actually build a model using machine learning to solve real world problems that you can deploy so other people can use this solution in on their phone or wherever you want to deploy it to for them to use. And I will be showing the next slide now on data science ethics. So data science ethics is like you imagining you yourself having a box of crayon, and each piece of crayon in that box represents an information. What is information? Basically, information is processed data. So after you've gotten your data, you've processed it, that is the information. And now that you draw a picture with those crayons, you want to make sure that anything you draw with that crayon is actually fair and kind. You don't want to, hurt anyone or misuse the information you have. So ethics in data science is like being an artist, a good artist at that with those crayons. You need to make sure you are using the data in a nice way. So ethics in data science actually encompasses principles and guidelines for responsible and ethical data handling. Okay, let's take for example you have a data, and the data is something you wouldn't want anyone or everyone to see, right? And then someone approaches you with the talk of, okay, I want to actually build a solution with this data. Can you give me permission to use this data? you wouldn't want to maybe see the data flying around social media everywhere, or the data being in the hands of people you don't trust. Okay, so as data scientists, we actually consider some things, and those are the things we hold on to as ethics. As much as we deal with data, we also have to make sure that we are using the data we get in a fair and kind way. Okay, so the first thing here is privacy. Data scientists need to make sure they are only using information that people are okay with sharing, and they have to keep it safe from people who should not see that data. And also fairness, you have to be fair when handling data. You don't want to tweak a data to suit your whole purpose, right? You have to make the machine do its thing, make it fair and kind. In data science, fairness means making sure that everyone is treated equally and nobody gets left out. Let's say you are working on a model, after getting your data, you are working on a model, and in the model, you are tweaking it to, limit some race, some gender. That doesn't really preach fairness. Okay, so in data science, fairness is very paramount, and you don't have to leave anybody out because of their race, gender, or any other thing like that. Also, scientists need to make sure that the information they use is correct and reliable, so they don't make mistakes or draw wrong conclusions. Also, they have to think about how their work might affect different groups of people to make sure it's a positive impact. So examples of some ethical considerations like the algorithmic bias in lending decisions. Let's say you build a model for a financial company, and the model is just very, very biased in the sense that you only want the model to recommend loans to some particular race or gender, or so that is not, a biased model is not a good model, and that is not the ethics of data science. Also, responsible use of data in healthcare or surveillance applications. Okay, I think I already made an illustration earlier. Okay, so another one is, let's say you are seeing your doctor, you trust your doctor to keep your information safe, and in the hospital, an app is about to be built, and of course, the app will be built on some, data. And after allowing the hospital to use the data, right? You need to you of course you would want your privacy to be kept, and also when the app is finally built, the app shouldn't be biased. Let's say the app is about um testing, or okay, when you input your information on the app, it can tell the individual that this person is liable to maybe have a particular disease or not, based on some inputs, some health information that you input on the app. Okay, so let's say someone that is not actually liable to having that disease puts his or her information on the app, and the app is just so, you know bad, and it gave the person a wrong result. That can actually cause maybe more health concerns for the person, or have more anxiety, or anything like that. So as data scientists, we have to keep to these ethics. We have to keep to them and make sure that we follow them, so as to have a good model that solves real world problems without causing harm to anybody. Okay, so in data science and machine learning, there are actually two types of machine learning problems that we have. We have the supervised machine learning and the unsupervised machine learning, or reinforcement learning. Okay, so supervised machine learning, from the term supervised means, okay, something having, a teacher or someone overseeing what is actually going on with the process. So in supervised machine learning, this is a machine learning approach where algorithms learn from labeled data, aiming to predict outcomes based on inputs or output pairs. So I'll quickly share my VS Code now to make you understand supervised learning and unsupervised learning. Okay, for supervised learning, I said okay, it has label and there is a teacher there to oversee what is actually going on with the process and all that. Okay, so the labels I'm talking about, if you take a look at the data here, at this data here, this table my cursor is on. So these square feet, bedrooms, bathrooms, neighborhood, they are all labels. They are labels for each column. They are labels for each column. So in supervised machine learning, this is an approach where algorithms learn from label data like what I showed, aiming to predict outcomes based on inputs and output pairs provided during the training. And under the supervised machine learning, we have two types. We have the regression and the classification problems. So a regression model predicts continuous values, of course, yes. For example, regression models make predictions that answered questions like what is the price of house in Nigeria? Actually, that's a continuous value. What is the probability that a user will click on this ad? It is not categorizing it into anything. Regression deals with, something of continuous value. While classification, on the other hand, a classification model predicts discrete values only. It actually classifies them maybe into two groups, three groups, or more groups. For example, classification model makes prediction that answer the following questions like, is this given email spam or not spam? So I believe that a lot of us or all of us use Gmail or Outlook to receive mails and send mails. Okay, so at one point or the other, we might have come across spam emails and emails that are not spam that are in our inbox. So actually, the explanation to that is that the mail model has been trained in such a way that it can flag off some keywords in mails. Let's say some words that look like scam, right, or fraud. It can actually flag it and put it in the spam box and not in the normal inbox for our emails. Also, is this image of a dog? Is this an image of a dog, a cat, or a hamster? So this is actually into three categories, and of course, it is still a classification problem. So in machine learning, let's look at the supervised machine learning workflow. So like I said earlier, after getting your data, maybe through questionnaires or surveys, you can proceed to data cleaning. And if you're working with secondary data that has already been collected or maybe cleaned, you don't have to, go through the first one. Just get your data then. You might not even have to clean if the data is already clean. And what do I mean by clean data? Clean data means, okay, the data is not having no values, or where the respondent is supposed to fill in names that is in word or sentence, that is a string. They did not fill in numbers, right? Because if they fill in numbers where they are supposed to write in maybe a sentence, that can give an error when working with that kind of data. So in that instance, you have to clean the data maybe by removing or filling the data with maybe with the mode of the column or the median. So actually this will be discussed more in depth in the next session. So you can proceed to cleaning the data. Then after cleaning the data, you split the data into train and test. You split the data into train and test. Like I mentioned earlier, supervised learning is just like a teacher overseeing everything. And let's come to the classroom setting. When a teacher is teaching students, right? He or she, after teaching them for some time, he or she would have to test those students if they actually understood what he or she has taught them. Okay, so same thing is applicable here. We have to make sure that we split our data into training data and testing data, and that is what this green bar is for the test and this blue is for the train. So after training the data with any algorithm of your choice comes about, and it should be about the supervised learning problems you are solving. If you are solving for regression, there are different algorithms to, train those model. And if you are solving for classification, also there are algorithms to also train them. So after training the model, you have to test the model. You have to test if the model is giving you the right answer, and you have to test if the model is actually doing fine by taking some tests like the accuracy test or any other test that you think fits would make you get the desired result. Then after that, if your model is not doing fine, you have to go back then adjust some model parameters, then also train the model again. And when you are done training the model, you have to evaluate the model to see that, okay, this model is okay, yes, I can work with this. Then after doing that, you deploy the model so people can use the model. So this second image right here shows the training and the testing splitting of the data. So we'll be checking some keywords in supervised machine learning now, and I would also be making reference to the Visual Studio Code I opened earlier. The first one here is the label or target variable. The target variable or label of a data set is the variable of a data set about which you want to gain a deeper understanding. And what do I mean by this? Okay, let's quickly check the Visual Studio Code. Okay, so for this data, these are the this is the data I will be making illustration with. Okay, so this price over here is actually the target variable. This is the data set of how same price in a particular location, and this data has been collected. It is actually a secondary data, and I guess it is clean. So these are the variables, right? But this is actually the target variable. We collected this data solely for knowing the price of house in a particular location, right? So this price column is actually the target or the label, because it is the one in which you want to gain a deeper understanding on. So that is the target variable. And in the example of spam, of email being spam or not spam, right? The label will be the category the email belongs to. That is this email spam or not spam? So predictor or input variable, right, are used to determine or predict target variable, also known as the input variable. They are also sometimes called predictor variable. Okay, so going back to the Visual Studio Code, these variables right here, the square feet, neighborhood, and year built, right? They are all input variables because these variables work together to predict the price of house in a particular location, right? So in other words, this price can be called the dependent variable because it is actually dependent on these four variables. It is dependent on these five variables rather, to work together to give its own value, its own value. And these highlighted variables are called the independent variable because they are not affected by this. They are the ones working to give the value for this. So this is the target variable, and this are the input or independent variables. So I hope you get that. And also in the spam detector example, the features could include the following, like the words in the email text, just like the data I just showed earlier. It showed the square feet, the year built, and some other variables, right? So for the spam detection example, for the input variables, we can actually have, columns like words in the email text, the sender's address, time of the day the email was sent. Email contains, the phrase like "Congrats, you won 1 billion." Actually, this kind of email, "Congrats, you won 1 billion," actually looks like scam or a fraud. So that is why it will categorize that kind of email into the spam box, right? So that is that about supervised machine learning. It is when data is being trained under the supervision of someone. So moving forward, we will understand the types of data we have now. We have the structured data and the unstructured data. Structured data is organized into predefined formats such as tables with rows and columns with relational data. This kind of data, right, they are in order, they are orderly, just like customer transaction in a retail database. Because as you get data from your customers, it will be in a database, and from that it is already in the right order and organized accordingly. This unstructured data lacks a predefined data model and can include text, images, videos, and sensor data. Like it contains, random. It has a lot of randomness in it. Like it can contain text, images, videos. So you have to start sorting this type of data before you can finally use them. So how do we work with relational data? Relational databases organize data into tables with rows and columns, where relationships between the tables are established using key and foreign keys, primary keys or foreign keys to, establish relationships between the data, right? So SQL, structured query language, is commonly used to interact with relational databases for querying and manipulating data. So this would actually be talked more about in the subsequent session, but I just want to brush through it for the beginners here. So when we work with non-SQL data, non-SQL data offers flexible data models and horizontal scalability, making them suitable for handling large volumes of unstructured or semi-structured data. And this include documents oriented like the MongoDB, key value, like the Redis, like that. And also this kind of data are really seen in real-time analytics, content management system, Internet of Things application, and social networks. So these data are actually very unstructured, and you can actually work with them using this, like the document-oriented databases, the MongoDB, which store data in a flexible, schema-less formatting as documents. And these documents can contain key value pairs, arrays, or even nested documents, allowing for rich and varied data structures within a single collection. So same thing with the key value stores, that is the Redis, and this is the simplest form of the non-SQL database where data is stored as a collection of key value pairs. Okay, so this is the slide where I'll go more into the Visual Studio Code to actually show some codes. And yes, Python is a high-level interpreted programming language known for its simplicity and readability. Me personally, I think Python is very awesome, and it is easy to comprehend and understand. Okay, so but for the scope of this session alone, which is for beginners majorly, right, I would only be taking you through the Python basics, and in the next session rather, right, we would be going more in depth into working with Python for data science, right? How you write Python codes for solely for data science purpose, right? So we'll be checking the Boolean values, the true or false, strings, text data, the arithmetic comparison, and logical operations. So I would open my VS Code now. But before I go to the Visual Studio Code, I made this announcement earlier, and I would also do it again right now. So if you haven't joined the Cloud Skill Challenge, you can join by going through this link. It will be sent to the chat section now. And also, if you haven't joined the Discord server, that is where we pass information and interact with one another for this bootcamp. The server will be active for this bootcamp, and also you can ask questions from mentors and the speakers we've lined up for this bootcamp. So make sure you join the Discord server. And also, if you want to read more on the fundamentals of data science and machine learning, I've written some articles on Medium, and so you can check that out. Okay, so going to the Visual Studio Code. So we'll be starting with the Boolean variables. So if you have this X and Y, X actually stands for a variable. X is a variable, and X can be anything. You can name it anything, your name, anything. So, but for simplicity, I'll be going with X. And a variable is like a container, a box where you store your information. So inside this container, that is the variable of X, I am storing this value of true in it. I'm storing this value of true in it. And also for Y, I'm storing value of false in it. So if I call X anytime, right, I can get Y. I can get true. And if I call Y anytime, I can get false. Okay, so let me quickly show that here. Okay. Let me comment this out. So if I call X, I'm going to get true because that is what I stored in X. And also, if I called Y, by writing just Y and hitting the run button, I will also get false because that is what I've stored in the variable. So that's just the simple definition of variable, right? And if you're talking about Boolean operations, it deals with the true and false statements, And you'll be seeing this a lot when you are working with, data in your Python, and you might want to perform some arithmetic operations or Boolean operations. So that is why I'm showing this today. So if you in Boolean operations, we have the and the or, not. There are different methods like that. Okay, so for this, if you print X and Y, we are using the print statement because we actually want to do more with X and Y. If I just want to get the value of X, I can just print X. And if I want to get the value of Y, I can just do that. Okay, so we'll be using the print statement here, and the print is, to show something. It's just like the console.log of JavaScript. So if I print X and Y, I will get the false because it is going through X, it is going through this true and false. And okay, if X is true and Y is false, okay, just give me the false, okay? And also, if you print X or Y, if you print X or Y, right, it will give us the true. it will give us the true. And if you print not x, it will give us false because x is already true, y is false, and you're already saying, okay, I don't want the x, I don't want the true. Okay, so not x, and the two variables here are just x and y. So that is why it will print the false here, because I don't want to deal with x, I only want to deal with the y. So that is why we got the false statement. And also string variables, string is like making a sentence, right? And for strings, we actually put them in quotes, If it is not in quotes, you will actually get an error, right? You get an error. So strings are always in quotes. And also this my string is also a variable, the variable in which we are storing, this data dive in. It's like a box, like I mentioned earlier, and we are actually storing data dive in it. Okay, so if you want to change this data dive into, uppercase, you want everything to just be capital letters, right? You use the upper method. You use the upper method, and going through that, it will actually change everything here to, uppercase. And also, we are using this print statement because the change in which we've done here is not going to affect what we've stored in our string. It's not going to affect it, other than just giving us the result we want at that moment. If we call this variable again, it's going to give us this data dive, with the one with the camel case, right? It's going to give us the data dive. Okay, so if we also print our string using the lower method, we are going to have the data dive all in lower cases. We are going to have the data dive all in lower cases. And also, if we print the length of the data dive we wrote here, the length, maybe we want to know the length of everything. So if we enter that, it has actually given us the length of the data dive we wrote in. So actually, this might actually look very easy right now, but these are the things you would also need when you are working with, real data, and you want to make more complex operations. But these are just the basics for you to understand. Also, going through the basic arithmetic operations, this A is a variable, B is also a variable, and inside them we've stored 10 and 5 respectively. So if we print A and B, that is 10 and also 5, that is subtraction, then the multiplication, and also the division. And this sign actually represents the modulus. It only shows the remainder. Since there's no remainder, we got the 0, right? And also, if we want to do a raised to power, we can also do it using the two multiplication signs, and that is 10 raised to power of 5. Okay, so moving on, let us look at how we can create a list. When we wanted to create a string earlier, we used quotes for it. Okay, we used quotes for it. So when we want to create lists, we actually use square brackets to create lists. We use square brackets to create lists. And the square brackets will make the, program understand that, okay, this person is actually creating a list. So in the variable called my list here, you can actually name it anything. It's a variable, right? So inside the variable, we are storing a list of numbers, right? Array of numbers, right? Okay, so if you want to print the length this this list, right? We've actually worked with length up there. So it is just using this len method, right? And inside it, we are calling my list. Okay, I want to print the length of my list. That is, I want to print the length of my numbers in which I've stored in the list variable. So, and it's going to give us the 5 because we only have 5 things in the list, right? Okay, so in Python, when you are counting from the left hand side to the right hand side, right, you start from 0 in the sense that this one will have an index of 0, the 2 will have an index of 1, 3 will have index of 2, so on and so forth, like that. That is from left to right. But if you are counting from right to left, right, you can actually start this 5 by -1, the 4 by -2, -3, -4, and -5. But we are counting from right to left, from left to right rather. It is 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So if you want to select the first number on this list, the first item on the list, and printing, using the print statement, if we set my list to 0, take note of the square bracket because that is how we specify the number on the list in which you want to select or call out. So print just the item having index of 0. And if we do that, of course, we are going to get 1 because it is the one with the index of 0. And like I said earlier, if you're counting from right to left, you can actually start this 5 by saying -1, -2, -3, because actually you can say 4 for this. That is 0, 1, 2, 3, 0, 1, 2, 3, 4, right? That is if you are counting from right to left, from 1 to 5, right? But if you are working with very large numbers, like lists of a very large list, to select the last number, right, it might take a lot of countering for you, so a lot of counts for you rather. So the last number is also -1 and the next is -2. So if we print my list and we want to target the item with the index number of -1, and that will be 5. Yes, that will be 5. Also, you can try this when you are less busy to know if you actually get that. Okay, so if we want to add more to this list, but we don't want to come here and add another number to the list, right? We can just use the append method. We can use the append method, that is my list dot append. In my list, I want you to append this. So if we append 6, 6 will be added to the list. So let's quickly see how the 6 is being added. Okay, so I'm calling my list now, and I have to run this. I didn't run this, sorry. So if I run this again, okay, the 6 is there now. I didn't run this earlier, that is why I didn't show it. So it has appended the 6. If you want to append more, you can actually do that. So if you want to remove from your list, that is from list dot remove, and what do you want to remove? You want to remove the 3, right? You want to remove 3. So doing that is that it has actually removed it, but because we are not calling the variable, it won't show it. So we can actually use the print statement to see that if you don't want to call the list as it is. So print my list. So it would have removed the number 3. It is no longer here anymore. So that is that. And okay, printing the final list. Okay, yeah, that is it actually. And okay, let's move forward to dictionary creation. Okay, so this actually might look easy now. Actually, it is easy, right? It is easy, but you would be using them. You'll be using all these things to solve, more complex problems in the subsequent session. So I would implore you to understand this very well. Okay, so this is another variable that is my dictionary. And in the dictionary, we have keys and values. Name is a key and John is the value. Also, age is a key and the 30 year is the value to the key. And city is a key, New York is a value, right? So if you want to just print out this name of John, right, you can just say print. Inside the print statement, I want you to print my dictionary, that is the variable. And what do you have to print from the variable? You can specify the key, and the key I'm specifying here is the name. Is the name. So I think the syntax is just a bit easy to comprehend, right? Print my dictionary. Inside my dictionary, I want you to focus mainly on the name because we have a lot of keys here. So I want you to only print the name key, and we are going to get John for that. Okay, yes, that is John. And also, the age here is actually 30. Is 30. And also, I want you to take note of the syntax for the dictionary. We are using the curly braces for it. For the list, we used the square brackets. And if you are working with tuples, we'll be using the round bracket. But we are not considering that for today. Okay, so if we actually want to append a new age, right? Maybe we made a mistake with John. John is actually 31 and not 30. So we can quickly do that by calling my dictionary variable and narrowing it down to the age in which we want to correct, then appending the 31. So if I run this and call out my dictionary, print my dictionary. Okay, John's age has automatically changed to 31. It's no longer 30, right? Because it was 30 here and here. We've already changed it to 31. Also, you can also change the, job. You can also change the job. Okay, job is not actually here. Okay, so now let us append job. Let us append job. In my dictionary, I want you to add job, then specify it to be a developer. So it's going to add that there. And if you want to correct also, delete this, you can see the delete here. Okay, yeah. So you want to delete the city from my dictionary. So at the end of it all, if you print the dictionary, you can see the change because city is no longer here. It has been replaced with developer, and the change of the age we did here is already there. All right, so that is basically it about the code. And in the subsequent section, you will learn do how to use this data and how to use data, how to get insights from them, and how to put the things you've learned into practice. Okay, so once again, if you haven't joined the Cloud Skill Challenge, you should join by going to a.ms/data-csc. That is the Cloud Skill Challenge. Join the Discord server to get more information, ask questions, and show us your progress as it goes. Also, you can read more on Medium about fundamentals of machine learning and data science. So thank you so much for having me on this session. If you have any question, I will take them now.
Hi, Eniola. Yes, we do have two questions. The first one, is it not required to declare variable type as Boolean? Not sure if I'm pronouncing it correctly.
Is it not required to declare variable type as Boolean? No, not so required. No, it's not compulsory. Since you've already specified the true or false, it would actually work when you write your programs.
And the second question is, what is the difference between array and list?
Okay. Okay, so array and list, right? Okay, so let's take for example, I think I should, can I get arrays and list here? Okay, so arrays, this is an array, and okay, this here is an array, and lists.
Sorry, we are not seeing your screen. It's not sharing here.
Okay, let me quickly do that. Sorry, a minute. Can you see my screen now?
No, not yet.
Okay, sorry. Okay, it is not actually my VS Code. Okay, so list can contain different types of, items. You can have string in a list. You can have numbers in a list. You can even have boolean in a list. But for arrays only deal with a single data type, right? You can't have different data types in an array. You can only have that for lists. Hope hope I have answered that.
Eniola, there is a third question. Why is Python more preferred for data science and machine learning?
Okay, Python is more preferred for data science because, like I said earlier, it is easy to comprehend, like, right? You can easily relate with the code syntax in Python. So a lot of people just, like using Python because it is it is easy to comprehend. That is just it. It is easy to understand. If you want to learn Python, it is very easy for you to, understand it compared to others.
Um, there is one more question. In your opinion, what's the quality Python has and makes it to stand out in comparison with other programming languages?
Okay, I think I have said that Python is easy to understand. It is very high level, and it is known for its simplicity and readability. If you are not so familiar with Python before and you see a Python code, you can easily relate with it, and it's just so simple to understand. It's very simple, and it's very readable compared to others. That is the striking difference I see between Python and other programming languages.
Uh, and that was the final question, Eniola.
All
I
right,
don't
thank you.
leave a final message, an invitation for other events to everyone before we finish. Oh, sorry.
Okay.
If you have time, there is another question.
All right.
Can we take it? Yeah. When variable type is not declared, how does the Python identifies between lists? arrays, any other similar types of data? Is it completely based on the syntax that we use?
Okay. When variable type is not declared, how does the Python identify between lists, arrays, and other similar types? Okay, like I said earlier, when you're working with list, right, you use the square brackets. And by using the square brackets, the program will actually understand that, okay, you are working with a list. And also, if you're working with arrays, right, you can actually specify that you're working with an array by using the numpy.array to specify that. And for dictionary, when you're working with dictionary, you can actually use the, the curly braces to declare that, okay, you are working with list. You don't have to like necessarily, state it. But if you're working with arrays, you can use the numpy.array, right, to make that known. So I guess you understand that.
Eniola, we are not seeing you.
Oh,
But
sorry.
I think right.
Okay, so list as I said, list are specified using the square brackets. They are specified using the square bracket. And if you're working with arrays, you can actually specify by, using the np.array, that is numpy.array. Actually, this would be, buttressed more on when Marshall takes the subsequent session. So that is why I didn't really go in depth into it. Also, if you're working with dictionaries, using the curly braces would, make the program understand that you're actually working with dictionaries. So sometimes you can specify for the array using the np.array.
Awesome.
So
I think that's all of our questions for today. Thank you, Eniola.
yeah, thank you everyone for joining in, and I will see you on the leaderboards and Discord channel.
Thank you. Thank you everyone for watching and engaging in our session today. For those who are asking if there's a recording, yes, this session was recorded live and it will be available in the Reactor YouTube channel in about 48 hours. Again, thank you for joining us today, and we'll see you in our next sessions here at the Reactor.